Welcome to this Agile software development overview. In this video, the first part is a live explanation on what Agile is and its scope. The second part shows how a team works the Agile way, and we see real demonstrations on how software systems should be designed to be changed frequently.
Have you ever thought that our profession is really important and is really great and it's fun, right? That's the reason we started in this profession. We like software development and we like the things that people do with our software. But sometimes we suffer and there's pain in the process and people get mad and users are unhappy. And there should be a better way to develop software. So imagine thousands of engineers, software engineers around the world thinking about this problem. How can we improve our profession? How can we be better? One of the answers to that question is called the Agile movement. The Agile Manifesto was like some big principles that were sketched by some professionals. And from that, there started a movement. And a lot of people started writing books and doing videos and demos on how to develop software more professionally and to get users to be more happy, be happier. Okay. So I will try to do an overview with you today. I will try to keep it simple and to give you an overview of Agile from the future perspective. Okay? When we talk about Agile, we'll say, okay, we want our teams to deliver changes early and frequently. We want to put software products in the hands of users as soon as possible, and that software should be able to adapt to changes, and our teams should be able to go fast and be excellent, and users are very happy all the time. And that's a hard problem, right? That's a hard goal. But we want to deliver changes early and frequently. Usually we start thinking, okay, if today we start a project, what would we do? And you say, okay, we will do sprints and we will do Scrum and we will automate the test and the business will be working with developers and a lot of good stuff. But somehow we tend to forget that in the future, 3 years from now, someone is supposed to work with that software too. They need to do changes to that software. They need to maintain it. They need to migrate it to new technologies, to implement new features. And 3 years from now, everything has changed. Just picture with me this scene. Other people will be the business people, other people will be the developers. There will be other business needs, other new requirements, okay? And the technology will definitely have changed. There will be new versions of the tools and it will be not web but mobile, and then when mobile dies, other thing will come soon. And today we develop APIs and tomorrow we will develop other things. But there will be a real business need, an existing code base. And we want developers 3 years from now to also be able to deliver changes early and frequently, even if they are not the same developers. And that is a harder problem even. But we should not speak that our team is Agile today and they are doing a mess with their code base and they are producing hard to understand code and but we are okay with that because they are doing Scrum. No. We need to think 3 years from now, we need to be successful with other people, other needs, other technologies. And that is the goal of Agile. So let's start here. Agile, to move Agile in an Agile way is to move like quickly, to adjust to changes, right? Like a rabbit, like an animal that can move pretty fast, that can adapt. So when we speak of Agile, we will be speaking of different topics. For example, it relates to collaboration. We need to think how people communicate and share knowledge with each other. We will speak also about how to plan a software project the Agile way, how to create a collaboration environment, keep planning and estimating and giving good project management to our clients. And the third point is technical excellence. How do you actually code? How do you design a software product that can be changed and morphed, transformed, fixed through this time, and maybe 10 years from now, it will still be existing, giving revenue to the users. So collaboration, planning, and technical excellence. Those are three perspectives we need to take into account. As I said before, everything started with something called the Agile Manifesto. They set some principles and some key elements that they think will make us more successful while developing software. The first statement of that manifesto is that people is really important, how individuals collaborate and communicate with each other. The second one speaks about the value of showing working software soon to users so that they can understand what are they asking from their requirements. At that time, we were used to create a lot of documents and just giving it to them and telling them, hey user, my dear user, I know you don't know anything about software development, but here is a 200 pages document that explains how the software will behave. It's not fair to them. No one can understand how a system works just by reading 200 pages documents. Okay? So the idea is that we need to show software to the people that will use it so that they can make up their minds and be very clear in what are we developing for them. The third statement speaks about how the business and developers should work daily together. There is a gap. They speak the business language and we speak the software developer language, and there's a large gap and we need to close it so that we can create the correct product for them. And also the fourth one states that we should create plans that can be adapted to changes. Planning is very important, but as I said before, people changes, and developer and the business needs changing, and there's new technologies during the lifetime of our project. So as everything is always changing and we don't have the skill to see the future, we need to create plans that can be changed pretty fast, that are good controls, that are formal, but can be adapted to changing situations. So that's the manifesto. People working software, collaboration, adaptive planning. Because we want to create a product. And the product should be the right product, first of all. Sometimes the business speaks in their own language, and we on the other side understand that a little bit and trying to imagine, and we assume things. And then we create a great product. It looks amazing, good code, but the user can say, okay, thank you, but that was not what I was thinking about. And in that scenario, we failed. We created the wrong product. So let's start for saying, we need some techniques, some ways to make sure that we are understanding the business. We are developing the right product. Secondly, we need to create a product that works the right way. Okay? We don't want to be rushing and creating the right product, but with a lot of defects. Maybe we understood that formula and the business rules, but we coded in a bad way. Maybe we did it pretty fast and we were awesome and we delivered to production. But if the product is full of defects, we are not being successful at all. So we need to create the right product, and it should work as as the user wants. And third, the product should be easy to maintain. Okay. And what is maintenance? Maintenance is to develop new features. Maintenance is to correct defects, because we will always have defects. It should be easy to correct, and it should also be easy to migrate to new technologies, because users should not be forced every 2 or 3 years to rewrite their whole application, because that's so costly, right? So expensive that people usually just stay with old technologies, and then they lose the value of their money with time. Because if you create the right product and it works great, but you can't adapt it to new needs, then we won't be as successful as we should. So let's go back to the first goal. Okay, we want to deliver changes early and frequently, today and in 3 years, with any software development team, with any business need, and with even new technologies. And that's a hard goal, right? But that's what Agile is about. It's accepting that we have a difficult profession, we got hard to solve problems, but there are some statements, and then behind these statements there are 12 principles that can help us to examine techniques and to start bringing practices to our teams in order to reach success in the form of a great product that can be changed frequently. Okay. So, just by placing this line from here to here, we are changing our mindset, because we cannot be focused just on the short term. Like, hey, your team should go pretty fast because you are agile, and in 3 months you get a release. No, we cannot think in a short-term way, and clients shouldn't also. We need to think mid-term, long-term, and develop that software that satisfies a business need on the long term. So in summary, Agile is about collaboration, it's about planning, and it's also about technical excellence. Now we will switch to the computer, and I would like to give some examples on how teams can start studying some techniques and practices and tools in order to achieve this. Okay? Okay, so we are here. I will show you some pictures and do some live demos very quick to show how in Agile we can do collaboration, how can we do planning, and how can we code and design a system in that sense of making it easy to maintain. Okay, because we want that technical excellence. So first, collaboration. How a team collaborates to create a maintainable product. We will always keep that in mind. It's not about the team. It's not about just how people are feeling happy. It's not also about project management. It's about creating a good product that can generate revenue for the users, for the clients. So let's start with a team. Okay? In a team, we usually have someone that knows what the client wants. Okay, we can call it like the driver. In Scrum, we call it the product owner. In stream programming, we just call it the client. And he knows about the business need. We also have someone that knows how to put the team members to work effectively and how to guide them through a process and how to teach good practices. In stream programming, we may call him a coach. In Scrum, we call him the Scrum Master. Okay? But someone needs to guide the team to prevent chaos from happening and helping them to self-organize and to be always learning and improving. So that second person, in that case, it's me. It's helping the team to get going. And then we got the whole team. We call them a cross-functional team because they have all the skills that are required to create a good product. People should be together, like here in this picture. They should be working daily together.
and then should trust each other so that they can ask questions, they can say freely, hey, I don't understand, I don't know, I get a need that you can help me with, I can help you with something. So a team should trust each other. This is an example of what we usually call the definition of done. It's the definition of what quality means for a team. This was drawn on a board, so that's why it looks like that. It's not pretty, but it's something that the team looks at daily. And they say, okay, we got a new requirement. And we will start working in that requirement. So here it says, okay, BDD test was written. BDD is a technique for specifying requirements, behavior-driven development. And there's a set of techniques behind that. The first one, so BDD tests were written. There was some analysis done on that requirement. And we designed the test cases so we know what is supposed to be done for this requirement. The second says, okay, we coded with unit tests, with integration tests, and they're used to say code was written. The third one, the code is in the source control repository Git, and the continuous integration build succeeds in the client, in the server, in the database. So technically, we are saying there that the software is checked automatically, is packaged and versioned automatically, is installed automatically in a testing environment. That is the fourth point, that it's deployed to testing. The fifth point, okay, there are some manual tests that we need to do in that product because there we are working on a website. And test cases were documented. Of course, there should be no bugs when we get to this phase and say, okay, the fifth point is done. And the sixth point is that the product owner, okay, our client, saw a demo of the product of that requirement, and he is happy with that. He validated that it's the right product for him, and then he gives a sign off. Okay, it's not formal, it's not a signature, it's just for him to say, okay, I saw the product. How much time does a team need to get from 1 to 6? Okay, in a good requirements splitting and organization, it should take a team 2 days, 3 days to get to that point. Because as we saw in the previous principles, we were speaking of, okay, we want to show working software early and frequently to the user. So you may say, okay, today is Monday, we will do the analysis for the requirement. I will get back to you on Tuesday, Wednesday, okay, so that we can get feedback. The point is that if we get it wrong, we want to know sooner than later. We do want to know that we build our wrong product in 3 months, okay, because the developer probably won't be on the team. And maybe the product owner forgot about the requirement. So we want to show progress pretty fast. Everything starts with an Excel sheet or some drawing that the product owner does. And it's ambiguous, it's not clear, okay? It's never clear, and also it's never correct. So we need to have some techniques to get these general ideas and transform it into working software that can actually be used right now by the product owner. Also, we need to have a way for the team to work together and do some analysis. Here you are watching at a real whiteboard where we said, okay, the analysis is composed by UI mockups, but we need to define data types, business rules, BDD specs, other test cases. Should it be a model screen, and define the test for that? We should have test data. Where is it supposed to come from for us to know that we are testing the product correctly? And on your right, You got also some explanation about API endpoints and changes we need to do to the database for the requirement. And probably you may say, okay, we do this all the time. Okay, yes, because if you get some software done in your life, you should do all this. The point here is that the team should be able to do this at a point of time where they can be together, where they can ask questions without fear, so that they can do a plan and start coding the right product. There are different techniques we can apply. Some of the techniques we can use are like this one here. It doesn't matter if you don't know all this syntax. It's called gherkin, but it's a way to put an ambiguous requirement into a fixed syntax in order to reduce ambiguity, to reduce uncertainty, and so that when I go into my coding tool, my IDE, I can know what is the definition of done for that business rule. So part of our analysis techniques should be BDD, or it's also called specification by example. We should have a well-defined way to know that we understand the requirement before we code. And then there's here another whiteboard. We should have a well-defined way of saying, okay, which tests are we gonna do? Which parts of the software should be automated with certain kind of tests, like here where we have a unit test. Other parts should be tested with integration tests. Other will be tested with end-to-end tests. We will see in a minute. Other parts should be tested manually, but our products should have a well-defined strategy on how tests should be executed. Sometimes we over-test. We test the same thing twice or 3 times, even though it's not required. And sometimes we don't test the products as deeply as we should. So the design of the software is very important in this part. Each responsibility should have well-defined tests. With that information, a good requirement analysis, set guidelines on how to do that testing part. The team should be able to create a plan, but it's a plan that they own. Okay, it's not a Jira task. It's not just something general that says create the requirement or code or test. It should be pretty specific, because now we got more information. It's not just an ambiguous idea. It's something that we have analyzed in a certain way, and now we can create a detailed plan. This is an example. If you have read or studied a little bit about Scrum, you know that there is a set board, the Scrum board, okay, where you got things that are in the to-do column, and then in process, and then done. Okay, there are different ways of tracking progress for the team. This is a different one, and I just wanted to show it to you, because here we got a daily plan for a week. In this project, we got a weekly sprint, a weekly cycle, and we developed, for example, here we were working on Friday on the user story number 5. And we started here working on the story number 2. So that means we worked on 4 stories during that week. And the most important thing is that the plan is for the developers. And each day we can track progress, and the team can adjust their estimates, their idea, they can adjust their specifications. The most important thing is that they do that together without interruptions. Okay? So that they can be very real, very transparent, and they can adjust accordingly to how we can be more successful in that cycle of work. Okay, I have spoken of cycles of work in different terms. We can speak of sprints, iterations. In this product, we called that week a drop because it was supposed to go to production weekly. So you may call it any way you want, a cycle or a development cycle. The important thing is that the team is the owner of that, and that the team is working together, and that the product owner is available for questions so that we can develop those requirements faster, but in the right way. And this is an example of useful documentation. Because remember, we are thinking of preparing this product for developers that will be working on it 3 years from now. So they need some high-level idea on which are the features of the product. In this example, each line is a feature. So you can say, okay, the first feature is a dashboard. And what is the description? Okay, it shows the list of cycle snaps for the given project. And then how do I get to that feature? And then how do I know which are the API endpoints? And then how do I test it? What specifications did the people from the past made so that I am, in 3 years from them, can understand what's happening in that software before going into the source code? So that's what I call useful documentation. Remember that we spoke before that working software is very important? Okay, yes, but as part of that product, we need to give some explanations so we can give context to the people of the future. And we get to the second point, technical excellence. Okay, we need ways to ease maintenance for the people of the future. Remember always that. So, how technical excellence helps us to change the software frequently. As we're reading here, things will change. So we should be able to respond to changes in requirements even late in the development process. So when things change, and in your right, you are looking at different software elements. From the top where we got a controller on the presentation logic. We got services, and we got controllers on the backend side, and stuff that makes business decisions, and stuff that makes the data access. Okay, all that design should have some tests, automated tests, that will be our allies in the future, because we will change that in the future, and we want to be sure that we are not introducing defects. So each of those parts should have some kind of test, like here, those green parts, unit tests. Purple ones, okay, that's tested for integration tests. In the presentation logic, you should have unit tests. There's another kind of test that are called snapshot tests. And then other parts require end-to-end tests, UI tests. If we got a whole strategy on how the app is designed to be easy to be tested, then those tests will help us to do changes faster in the future. Okay, it may be a week from now or 3 years from now, with the confidence that we are not introducing regressions into that code base. And the key for that is design. Okay, design always in mind. Okay, so let's think that we are 3 years from now, and we are supposed to do some changes to this application. Okay, as the name says, it's called Gift. It's a metrics tool, and we got a lot of information here from projects to know if they are behaving the correct way and if we are getting valuable software to users. That's the goal of this tool, to track the maturity of the teams. And you got a lot of business rules in here. You got a lot of screens. We got a code base that is developing JavaScript, and the presentation part, and the backend part is with Java. The database is MySQL. And you are the new developer, and you just know that. You have downloaded the source code, and you are thinking, how do I know if this is working fine right now? Because I need to implement a new requirement in this screen.
The idea is that you can go to some place and, for example, here we will run all the unit tests, automated tests that are asserting that the backend part is working just fine. The main point of a unit test is that it's a piece of code that examines the existing code base, and you trust that if some of them fails, it's a definitive proof that there's a defect on the software. If your unit tests sometimes fail and you doubt that, then you should delete that tests, because unit tests should be very useful in this way. So here you are reading that it says build successful, all the tests ran successfully, and I got a report here. We just run 87 tests. They took less than a second. Here you may read less than a second. And we got the information for all the tests that run. But because they are green, we trust that the software is behaving accordingly. How do you get unit tests to run that fast? Okay, design. The key is software design. Designed to make software easy and fast to test. Then you may say, okay, I need to install the database. Okay, you should have a single command to set up your database and your test data, and the same for your website, and the same for your API endpoints. And that should be automated. That should be really fast, so that you can say, okay, now I will run the backend part. That is what I'm running here. I will run the website. I'm running it here also with a single command. And I would like to run also the unit test for the JavaScript part. The other ones were Java. These are JavaScript, but they should comply with the same principles of maintainability and of trust. Here we got more tests. We got 260 tests. They run also pretty fast. Okay, and then you say, okay, I already installed the database. I would like to know that my integration points are working fine. I'm targeting the database, that the HTTP endpoints are working fine. And here we will have like 4 or 5 tests. We will read them in a minute, because they are checking that the application is correctly installed in my local environment. That's it. It took 20 seconds. Okay, not as fast as the unit test, but there are few integration tests, so they're still pretty fast. We can read the report here. We got 4 tests. That makes me be sure that the app is correctly configured in my local machine. So it's a combination of different kinds of tests. There are some parts that are not exercised with these 2 kinds of unit tests and the integration test. So there are other kinds of tests here. We call them end-to-end tests or UI tests, that according to our design strategy of the whole application, they will target the UI. And we will see the UI in a minute working automatically, with also tests that we trust, simple tests that are easy to maintain, but are doing something valuable. Here we are loading the web page, and then we are checking that things are working just fine. And yes, this is real code that we developed it here. And we are testing events here. That events are working just fine. Again, to build trust that the application is working correctly now before I do any change to the source code. We run here 6 tests. It took 31 seconds. So 31 seconds here, 20 seconds for the integration tests, less than a second for the backend unit test, like 10 seconds for the JavaScript unit test. So that means that in less than 2 minutes, you can have a whole system verified by itself. What is required to build a system like this? Okay, we need a team that is well trained. We need the correct tools. We need a strategy. We need to support them because we are not thinking short term. We are thinking on the success of the product in a long term way. Okay, so these practices are not specific to Agile, but the people that spoke of Agile in 2001, they were the creators of unit testing frameworks. They spoke always about design patterns, about refactoring techniques. For example, in extreme programming, it's a great set of practices. They speak about continuous integration. Continuous integration is, like we are looking here at a tool called Jenkins. It's something that helps developers, a practice that helps developers to commit changes frequently, every 2 hours, every 3 hours. And it will automatically run all the tests that I showed you before, so that people can know, okay, is everything working fine? Yes, in 3 minutes you can know. And here, for example, we got the report of the backend integration test, the backend unit test. We gotta count at all the tests that are running. And on each commit of the developer, this process will give us feedback, valuable information to make sure that everything is fine. And when someone makes a mistake, okay, this will be a safety net so that we don't release software that has some bug into the testing or the production environment. And this process takes 3 minutes. In 3 minutes, you got all this valuable information, and you can also deploy the application automatically to the environment. So that's the environment, as we are doing it here. So technical excellence is not just that the application works. It should be the correct requirement for the business user. It should not have defects, but if it has, we should be able to discover it sooner than later, and it should be easy to maintain. And that leads us even to go to how are developers naming variables, naming classes, how are we organizing the source code. All of that is key for our success in the midterm or long term. And what is good planning? People like to call it agile planning. I like to just say a good plan. Okay, a good plan is something that answers that question. Can we tell the story of our project and the impact of the changes? For example, here we got what we call a release burn-up chart, and we are showing the project status. We got sprints on this axis, and we got the scope. Here we are using what we call user story points. And on the green bars, we got the deliverables that the teams are making every 2 weeks. So you can see that it changes a lot. Sometimes we deliver a lot, like here. And sometimes we don't deliver anything. This is the story of a project that took us more than a year, more than a full year of development. And users were always changing their minds. And while we were delivering software, like you see here, okay, this is the accumulation, the sum of all the points that we were delivering. In the red line, you see that users were always changing their minds. They were cutting the scope or adding the scope, like here. And that's the reality of software development. The thing is that many times we don't give visibility of that. And sometimes we end up working weekends because users change their minds, because requirements were not clear, because software is hard to maintain. And all that just creates a mess on our projects. So when you take a look at this picture, you should get a feeling of how developers were feeling. We even created some software, and a month from that, in the future, the users were telling us, no, delete that, we don't need it. But that's the reality.
And this graph, this chart, helped us to explain what was happening so that everyone was clear on expectations and nobody was stressed out because we were not hitting deadlines. And in this project, we did like 6 releases through that year. So we were delivering. The users were happy because they were getting the product little by little. But the important thing that I wanted to show you here is that a good plan tracks and adapts to scope changes first. Okay, we are clear and we are transparent. We can do time forecasts. Each requirement change should trigger a new calculation so that we can tell our users, okay, I told you before that we were releasing a month, and with this new change, it changed to 3 months so that they can make informed decisions. Here we are tracking also the velocity of the team. That means that how much software are they delivering on each sprint. And the capacity, how many developers, because as we said earlier, we started, for example, this project with 6 developers, and after 2 months, two of those developers resigned from the company. They quit, and we need to give visibility of the changes according to how the team changes also. So the team capacity, and how frequently are we releasing software to production? And when we do that, we may get also incidents. So we need to track all of that. Some people say, okay, you are doing Agile, you don't have a plan, you don't know what's happening, you are just throwing a lot of code into production and it's crazy. No, Agile is a pretty disciplined method and practices, and people should be that disciplined as well. So let's finish just with this summary. Agile software development. Okay, there are different ways to deliver changes in a software system, but we want that to be early and frequently. This is not a silver bullet, a magical solution. It requires a lot of studying, discipline, tracking, learning, right? Feedback. But with this small talk, I just wanted to focus on those 3 perspectives. We want people to collaborate better. We want technical excellence, and a planning way that can help that people to be more successful and transparent. Okay, so thank you very much for your attention, and remember that it requires a lot of studying. It's not easy, and I'm not saying at all that it's easy, but I think it's worth it. We can be better professionals with all these ideas and books that we can read. So thank you.